So, like I said, depending on the wording of the problem, it's up to us to determine whether we need to use the average rate of change, which just has to do with the slope of the secant, or instantaneous rate of change, which has to do with finding the limits for the specific point at x is equal to a. So as you can see, the first one, all we had to do was find the average rate of change, which is basically just y1 or y2 minus y1 over x2 minus x1. Okay. So now, using that same equation, which was st is equal to 10t minus 5t squared, we need to figure out the velocity at the ball at 3 seconds. So since the word average is not in the question, we have to assume they're talking about instantaneous velocity. So when it comes to instantaneous velocity, we're going to have to find the limits, okay? So what would be our a value in the limit in this case? What would our a value be? Remember, it's the value at which you're trying to find the change at. Thank you, Ian. It's going to be 3. So I need to find the velocity at 3 seconds, which is going to be finding the limit as h approaches 0 of s of 3 plus h minus s of 3 all over h. And just like we've been doing before, wherever we see t, we're going to plug in 3 plus h. So my next line is going to look like limit of h approaching 0. We're going to have our square bracket 10 times 3 plus h minus 5 times 3 plus h squared minus s at 3, which is 10 times 3 minus 5 times 3 squared, and that is going to be all over h. So now all that's left to do is we have to simplify. So we got the limit as h approaches 0, and we're left with 30 plus 10h minus 5 times 9 plus 6h plus h squared minus 30 minus 45. So that's all over h, which means we're left with the limit as h approaches 0 of 30 plus 10h minus 45 plus minus 30h, sorry. So minus 45 minus 30h minus, sorry, the square should be in here, ignore that, minus 5h squared minus 30 plus 45 all over h. So what you're going to start to notice is our 30s cancel out, our 45s cancel out, and we are left with the limit as h approaches 0 of negative 20h minus 5h squared all over h. So remember, the point here is to get rid of the h. So what can I factor out from my numerator? So what can I factor out from my numerator? H. So we're left with the limit as h approaches 0. So we get h minus 20 minus 5h over h. So you cross these off. Because it's h approaching 0, I can just sub in 0 for h. So I'm left with negative 20 minus 5 times 0. And that gives me negative 20 meters per second. Okay? So obviously, like I said before, we cannot have negative speed. So for all you guys taking physics, I don't know if you've been introduced, when we have a negative velocity, what does that tell us about the velocity? It's not stopping. Think of it in terms of a direction. It's going down, okay? So when it comes to positive and negative in velocity, it just tells us the direction. So in this case, therefore, the instantaneous velocity at 3 seconds is 20 meters squared going down. So whenever we have a parabola and we have our, slope, our velocity as we continue to go down is negative because of the downward trend in the parabola. That means it's going back to Earth's surface. Okay? So is everybody okay with this example? Any questions about this example? Feel free to ask. Okay, so it sounds like we're all good. So what comes next is more examples. So this time we have a function st is equal to 60t minus 3t squared, where t is in between 10 and 0. Describes the distance in kilometers that a car has traveled after time t in hours. So I want to determine the velocity of the car where t is equal to a. So are we finding instantaneous or average velocity? Because the word average is not in the problem, we are going to be finding instantaneous velocity, okay? Whenever the word average is not in the problem, always assume instantaneous, okay? So when we're finding instantaneous, can we just simply take the change in y over the change in x, or do we have to figure out the limit? Okay, we're gonna use our lovely friend, the limits. Which requires a lot of steps to get us to a equation of a tangent line. So we want to determine the velocity of the car at time where t is equal to any a value. That is the formula that we're going to use to find the instantaneous velocity at that point in time. So velocity of a is equal to the limit as h approaches 0 of S of A plus H minus S of A all over H. So again, as you can see, this gets a bit repetitive, okay? We are finding the limit to see what our velocity is going to be at any part of the graph, wherever t is equal to a. We get the limit as h approaches 0. Remember, wherever you see a plus h, or wherever you see a t, you're going to sub in a plus h. So we're going to get 60 times a plus h minus 3 times a plus h squared minus 60 times a minus 3a squared. Close bracket, and that's all over h. So now what we're going to do is we're just going to try to expand and simplify. So we get the limit as h approaches 0. So we get 60a plus 60h. We get minus 3a squared minus 6ah minus 3h squared minus 60a minus 3a squared all over h. Okay, I skipped the step because I know a plus h is just a squared plus 2ah plus a squared, and I just skipped that step because it was an easy expression to work with when it comes to a perfect square. Okay, so now that we have our numerator and denominator, what does our numerator simplify into? Feel free to type your answer in the chat. What does our numerator simplify into? Once you're done, just type your answer in the chat.
Sir,
Yep.
when you're distributing the negative in the second answer, would you not make the 3a squared positive?
Oh yes, my bad. Positive. Oops. Thank you for that. That makes it easier now. So we get 60h minus 6ah minus 6h squared. Okay. So we get the 3's cancel out because of my mistake. Sometimes it happens. Our 60a's cancel out. And we are left with 60h minus 6ah minus 3h squared all over h. Okay, sorry to Kushbu, I kind of messed you up when I didn't change it from a negative, when I didn't change it from positive to negative. That was my mistake. So all I can do now is factor out an h from my numerator. So my h's cancel out, which means I can just sub in 0 for h. And what would my v of a give us as our final answer? So when I sub in 0 for h, what would my velocity equation B? Thank you, Priyanshu. 60 minus 6a. So, to find the velocity at any t value that equals a, we're going to use the equation or the velocity function 60 minus a at whatever value we assign a to be. Okay. So I'm going to move down a bit. I'm going to put it right here for those who didn't get to copy it down yet. So now determine the velocity of the car at the times t is equal to 3 and t is equal to 5. So what are we going to do to figure out the instantaneous velocity at 3 and the instantaneous velocity at 5? What are we going to do? So we're going to use the equation we made and sub in our values. So we're going to have v at 1, and we're also going to have v at 5. So this is equal to 60 minus 6 times 3. Sorry, this is 3, which is equal to 60 minus 18. So my velocity, where t is equal to 3, is going to give me 42 kilometers per hour. And my velocity, where t is equal to 5, is going to be 60 minus 6 times 5, which equals to 60 minus 30, which is going to give me 30 kilometers per hour. So if you guys notice, as the time increases, what is actually happening to the velocity of the car, given the 2 times that we have here? Is the car getting faster or slower? It is slowing down. Okay. And then I want you guys to do C on your own, and someone's going to give me the answer or tell us how to do it. So we have at what time is the velocity 12 kilometers an hour? Okay, so this is again basic algebra using our velocity function. V of A is equal to 60 minus 6a. I'll give you about 3 minutes to do this. This shouldn't take too long. So at what time is the velocity 12 kilometers an hour? Okay, let's see. Someone who has not. Okay, someone who's not Madge who wants to talk. Can you explain what we did or what you did? Anyone want to speak? Okay, Anna.
So basically I arranged my equation as 12 equals 60 minus 6a. And then I brought the 60 over to the other side, so it's 60 minus 12.
Okay.
And then to cancel out the 6, I just, well, first I subtracted the 60 from the 12, and then I got 48, and then I divided 48 by 6 to get 8.
Okay, perfect. So our A value is going to be 8, which means the velocity is 12 kilometers per hour at 8 hours, because remember, time is in hours. Okay, thank you, Anna. There are 2 more examples for this lesson, so we'll try to get through those. This one isn't that bad. So are you guys finding limits to be a bit more easier now? I know the work is tedious, but are you guys at least finding it to be a bit more easy? Yeah, the fact that you have to go from S of t to S of a, and then just doing that just makes it confusing. The only reason why that happens is because time is equal to the a value, which is the x coordinate of the point that you're trying to find the instantaneous velocity at. That's the only reason why it becomes difficult. Basically, t is equal to a is equal to t. So that can confuse some people right there. So we're going to do the last 2 examples for lesson 1.3. And then lesson 1.4 is about a limit. We've been doing limits. I don't know why there's a separate lesson on just limits, but that's the way that's the way it is sometimes. So the first one is easy. An oil tank is being drained for cleaning. After t minutes, there are v liters of oil left in the tank, where vt is equal to 50 times 30 minus t squared, where t is between 30 and 0. So we want to find the average rate of change of volume during the first 20 minutes. So you have to find the ARC, average rate of change, or AROC, whatever you guys like calling it, is equal to what? So remember, that's the change of y over the change of x. So how am I going to find the average rate of change? What will my statement look like, or expression look like to find the rate of change? So remember, we're finding it between the first 20 minutes, which means that we will use what t values, or what would be the best t values to use in this case? Okay. 0 and 20. So we're going to do the volume at 20 minutes minus the volume at 0 minutes divided by 20 minus 0, which is just 20. So if I calculate my volume at 20 minutes, what does that give me? So V of 20 is equal to 50 times 30 minus 20 squared. What does that give me? What is my volume at 20 minutes? $5,000 liters. And I need my volume at the start point, which is 0, so it's 50 times 30 squared. What would my volume be at the very beginning when no time has elapsed? $45,000. Thank you. So we get 5,000 minus 45,000 over 20. And that's going to give me an average rate of change of negative 2,000 liters per minute, which means we are losing an average of 2,000 liters every minute in the first 20 minutes. Okay, so you guys can probably assume what's going to come next. We're probably going to have to find the rate of change at a specific time t. So we want to find the rate of change of the volume at t is equal to 20. Because it's giving us a specific point that we have to find the rate of change at, we need to use the limit, okay? So the instantaneous rate of change, where t is equal to 20, means we have to find the limit as h approaches 0 of v of 20 plus h minus v of 20 all over h. So remember our formula is going to be Vt is equal to 50 times 30 minus t squared. So this is going to be our limit as h approaches 0 of 50 times 30 minus 20 plus h squared. Minus v at 20, which we know is 5,000. And that's going to be all over h. Now we have to simplify our bracket. So we get 50 times 10 minus h squared minus 5,000 all over h. And we get our limit as h approaches 0 of 50 times 100 minus 20h plus h squared minus 5,000 all over h. So now we can simplify my numerator as the limit approaches h approaching 0 is 5,000 minus 1,000h plus 50h squared minus 5,000, and that's all over h. And as you can see, my 5,000s cancel out, and I'm left with the limit as h approaches 0 of negative 1,000h plus 50h squared all over h. And you guys can probably assume that we are going to factor out an h. So we get h negative 1,000 minus, or plus, sorry, 50h over h. My h's cancel out. So once I sub in 0 for h, what is my rate of change at 20 seconds? So what would my rate of change be at 20 seconds? It would be negative 1,000 liters per minute. Which means that the tank is decreasing at a rate of 1,000 liters per minute at 20 minutes.